Welcome to video 2, Building a Circuit. In this video, we will discuss the design of the breadboard and how you can utilize it to build your own circuit. The breadboard makes for easy experimentation with circuits in lab because of its simple point-to-point connectivity. To use the breadboard correctly, it is important to know more about the inner workings. The breadboard is divided into rows and columns, which create different sets of nodes. A node refers to any point on a circuit where two or more circuit elements meet. On this breadboard, each row within each of the 4 columns is a single node. The 4 columns are divided by either a source bus or a groove. Each of the 6 source buses are generally used to provide a single node of either voltage or ground for easy access in each row. To simplify our sourcing, we have connected all red buses together and all blue buses together with wires at the bottom of the board. Note that without these wires, each red and blue bus is its own individual node. The cable input ports at the top of the board provide easy sourcing of voltage and ground from an external source. Simply unscrew the knobs and insert a wire underneath to connect these inputs to either a row or source bus on the breadboard. The breadboard is useful for building all kinds of circuits, including digital circuits using DIP ICs. DIP stands for Dual Inline Package, and your breadboard is specifically designed for use with these types of integrated circuits. The grooves are specially placed to provide for placement of these types of ICs. Note that this placement provides each pin with its own row for connecting other elements to its node. So now that we know more about the inner workings of the breadboard, let's use that knowledge to actually build a circuit. We'll take this circuit for example. We have 3 different ICs that will have various interconnections. The first thing to keep in mind when building a circuit is neatness. This means placing the ICs in a logical fashion, using as few wires and as few connections as possible. Once your ICs are in place, make sure you connect power and ground to all the ICs according to their datasheets. Once your ICs are connected and powered, you can proceed with making the interconnections. Notice that in building our circuit, we tried to reduce the number of wires used and to keep those wires flat to the board. We tried to avoid crossing wires over other wires and from crossing them over the ICs. All of this will help us later when we connect the circuits at the CADET 2 and in case we have to do any troubleshooting. Take note that this circuit is rather simple, but following these guidelines as closely as possible will help in even more complicated circuits. Finally, with the main part of the circuit built, we will add nodes for the input signals. We have designated one node or row for each input by placing an orange wire in rows 2 through 5. We will name the rows from top to bottom in alphabetical order, W through Z for our input signals. You can order them in any way you want, but by placing aside one node for each input signal, you can keep track of where in your breadboards the inputs are, which will make troubleshooting a lot easier. We can do the same for the output. So now we have a circuit that we can test on the CADET 2 board. This concludes video 2. In video 3, we will see practical uses of the CADET 2 board and test the circuit we have built here. Thanks for watching.
Technology, buy it, use it, break it.